algebra and dealing with systems of linear equations, you may recognize these types of problems. What we have here are two equations that must be solved, and we want to solve for x and y. We want two numbers, one number representing x, one number representing y, that solves both of these equations. So let's get started. The first equation reads 2 7/10 x plus 1 5/10 y equals 36. This top equation is in the order that I like to work because the x is in front of the y, because that's ABC order. You have the equal sign and then a constant, which is 36 on this side of the equation. This one, on the other hand, is mixed up. So we have 3 5/10 y equals 2 7/10 x minus 6. I can't work this and this at the same time, so I need my x here to align with here. I need my y's here, I need my equal here, and I need my numbers over here. The beautiful thing about math is you can turn things around. So I can take this whole piece on this side of the equal sign, put it over here. I can take this whole piece and put it over there. So that's what I'm going to do now. So that means I'm going to have 2 7/10 x minus 6. And I'm going to flip this and put it over here. All I'm doing is copying down. This is not rocket science, ladies and gentlemen. This is very easy. I just copy this, put it here. I just copy this, put it there. Now I almost have it in alignment, but I want my y's here, and I want this number to be over there with the equal sign remaining in the middle. And so this is where some of your algebra work will begin to come in. I want to subtract this from this side and put it over here. Notice I said I want to subtract this, which is 3 5/10 y. My writing will get better as time goes on. This is literally my first video and probably my first time really focusing on writing on the board in many years. And I want to subtract it from this side because I want numbers on this side. I want the y's over here. So if I subtract from one side, whatever you do to one side, you have to do to the other side. So I'm going to subtract minus 3 5/10 y from the other side. And that looks like, well, what in the world do I do? Don't get confused, ladies and gentlemen. This is very, very simple. All I'm going to do is copy down what I have. I'm going to put it in order, though. So now I have 2 7/10 x. I'm going to go ahead and copy this down. Minus 3 5/10 y. And then I'm going to copy this down, the negative 6. Minus 6 equals, and don't let this confuse you. If you have anything and you take that same thing away, that answer is 0. That was the whole purpose, to get these y's away from here and put them over here. It's just a copying down strategy. That's all we're doing. So now I want my number that's by itself, my negative 6. I need to get rid of that. And the only way to get rid of that is to add 6 to both sides. And now I do the same thing I've been doing. I'm going to bring down my 2 7/10 x minus 3 5/10 y. This is 0. If you have a 6 and you take away 6, 6 minus 6, or negative 6 plus 6 is all 0. Doesn't matter how you write it backwards or forwards, it's still 0. And 0 plus 6 is 6. Now I have it in the x, y equal constant form, which is what I want here. So I'm going to take these two, this one and this one, and I'm going to rewrite them right over here. I'm going to divide this up so you can see. So I'm going to keep this up top. I'm copying again. Plus 1 5/10 y equals 36. That's the first equation. The second equation, which was this one, which I turned to this, which I turned to this, which ultimately became this. I manipulated that equation. Same numbers, same variables, same coefficients. The 2 7/10 x is right here. The 3 5/10 y is here. It became negative because it switched sides. And then my 6 is here. It became positive because it switched sides. And my equal sign remains. So I'm going to take this and I'm going to write it under here. 2 7/10 x minus 3 5/10 y equals 6. Now, I can begin my process of elimination. I have the equation set up like I want to, and the reason I know that is because I have two similar or exactly the same coefficient and variable in the front, which makes it very easy for me now to subtract this one from that one. But to subtract, I need to put everything in that equation and make it a subtraction problem. I just can't subtract this. If I subtract this, then I got to subtract that, then I got to subtract this. The only way to do that is to subtract the whole thing. And when you're dealing with equations, whatever you do to one side, you have to do to the other. So this minus sign, because I'm trying to eliminate the equation down to one variable, is going to now look like this. I'm going to actually rewrite this whole thing again. Think about math, you can't be lazy. Sometimes when you're lazy, you mess the problem up. So I'm just going to copy this all again. 2 7/10 x plus 1 5/10 y equals 36. Now I'm going to do this part. The opposite or the negative of 2 7/10 x is minus 2 7/10 x. The opposite of a negative, or negative times a negative, if you will, or the opposite of a negative is a positive. 3 5/10 y. My equal signs here, just bring it down. And the opposite of 6 is negative 6. Now, I can combine these two equations, taking step by step. 2 7/10 x minus 2 7/10 x. If I subtract these two, that's 0. Anytime you have the same thing on the top as you do on the bottom, and you're taking one from the other, whether the top is negative or the bottom is a negative and the opposite is positive, this right here is going to be 0. So I'm not going to even bother to write that down. That just confuses things. So that's gone. So if I add 1 5/10 and 3 5/10, that's like $1.50 and $3.50. Or it's 1 5/10 and 3 5/10, just like I said. Hopefully, if you're doing this level of problem, I don't have to break this down. I will do problems where I have to break these decimal numbers down and how you have to line the decimal up, but we're not doing that today. This is simply 5.0 y equals 36 minus 6 is 30 all day long. Now also, if you're an algebra student, you already know you don't need that 0.0 on the back. 5.0 is the same thing as 5, which is what I've written. I've got 5y equals 30. And of course, you know that is a one-step equation. That is a multiplication equation. So 5 times y equals 30, or 5 times what equals 30. You know the answer. We already know. It is 6, but you're going to divide both sides by 5 because you do the opposite of the singular equation. So of the single step equation, I should say. So 5 times y equals 30 means you need to divide. You do the opposite of multiplication, which is to divide both sides by 5. These will give you 1. 5 over 5 is 1. That leaves 1 what? 1y. I got 1y equals 30 divided by 5, which is 6. So now I know that y equals 6. For both of these equations that we started with, we know that this y will be 6 and this y will be 6. Now we have to figure out which number will represent x. And the only way to do that is to take this 6 and plug it into one of these original equations. It does not matter which one you choose. I'm going to choose the top one for consistency, just to keep things in order. The more order you maintain with your problems, the more you will be able to be successful in mathematics. Mathematics is the key to college, by the way, ladies and gentlemen. It is the gatekeeper. Specifically, Algebra 1 is the gatekeeper to your college entrance particularly in this technological age where we code a lot and we have a lot of computers and technology in general, algebra is key. You have to know how to read, of course, but algebra, 9th grade algebra, preferably 8th grade algebra, is the key. 2 7/10 x plus 2 7/10 x plus 1 5/10 y equals 36. And we said the y equals 6. So I'm going to go back in, 2 7/10 x plus 1 5/10 y, but we said y is 6. So instead of the y, I'm going to put times 6 equals 36. All right, I took my y, I did all this work over here so I could find one of these variables. I found y, I substituted y into the top equation right here, right behind the 1 5/10, and I placed it here. So let's do some work. 2 7/10 x plus, now if you are in the lower grade and you don't understand how to multiply 1 5/10 times 6, you can do some Mickey Mouse work over here. Looks like that. And you go 5 times 6 or 6 times 5 is 30. Here's your 0. You carry your 3. You know this stuff. 6 times 1 is 6 plus 3 is 9. You got one number behind the decimal here in your multiplier. So I'm going to put one number down here in my product. So 9 0/10, which is the same thing, ladies and gentlemen, as a good old-fashioned 9. That's like having $1.50 6 times, or $1.50 times 6 is $9. So that's a 9 equals 36. I'm getting very close. This is a two-step equation. Why? Because I have to do two things to solve it. I have my variable and I have my numbers, my constants, but I need this number to be over here with this number, and I have to do the opposite of this. So this says add 9. To get rid of this 9, I need to subtract 9 from both sides. Whatever you do on one side of the equation, you must do on the other. 9, take away 9 is 0. Boom, that's gone. I don't need that anymore. I'm not going to even write it down. I could write it down. That's just something else I have to deal with. If you're in algebra, you understand 9 minus 9 is 0. So only thing that is left is this 2 7/10 x. This is 0. Don't bother writing it. Boom, boom, equal sign. I'm just copying. 36 minus 9 is 27 all day long, all day long. Now that's looking nice and pretty because now I have a one-step equation that boils down to asking yourself, what number can you multiply times 2 7/10 to get 27? And since this is a multiplication problem, because the variable x is next to the coefficient 2 7/10, I have to do the opposite of multiplication, which is to divide both sides by 2 7/10. 2 7/10 becomes division. Again, 2 7/10 divided by 2 7/10. That's a fancy way to write the number 1. 1 what? 1x. I can write a 1 right there. Boom, 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 boom. I could put a 1 right there, but it's still an x. Because if I erase it, how many x's do you see? It's still 1. All right, so I see 1x equals whatever this is. Now, we already know what the answer is. But in case you forgot how to divide a whole number by a decimal number, you put this and put the whole number on the inside because it's up top. And I notice I have a decimal here. I cannot have decimals here, so I move it one place to the right to make it a whole number. And then whatever I do out here, I need to do out here. So I have to move this decimal. Only thing is I don't see a decimal. If you don't see a decimal, it's always in the back. It's right here. That's like having $27. If I put a decimal right there and add zeros, it's still $27. It doesn't affect anything. But I have to move it one time, and then it goes up here in my answer. So if you move it one time and nothing's there, what do you plug it in with? You plug in a 0. Pause on that for a minute. Mickey Mouse math. And now, I don't even need this anymore. That's a distraction. This is the